So now at this point, I've got my ground bus attached, the headers in. I made the first connection from this chip socket to this header wire over here. Basically, this wire runs through the hole in the perf board, and it's soldered on the back, and the tip is bent over and soldered to that pin on the socket. And let's try adding another pin. This next pin here is going to have to go, is the enable for, or excuse me, the enable is the top one. This is the, looking at my data sheet, that was the output. This is the input from that channel. So I want to run that to this pin right there on the back of this header. So we want to go down this hole, bend the lead over to touch that pin, solder it, come all the way across, and we'll solder directly to there. If the headers were on the same side, maybe we could go through a hole and do that, but since they're not, we'll just have to kind of make it up as we go along. I'll take a little bit of insulation here, put it on the lead, just so I have something. It's a little too long. Bit of a short out. That on there. Slide it down this hole. I can solder that to the perf board. A little bit of solder gives me that mechanical connection. I then bend the end of the lead over so it touches the pin that I want to connect it to. And just drop the solder, makes that connection. I really don't have any excess to clip, it moved a little bit. And then I can come over here. I don't like that. We're going to undo that one. Heat it up. Melt the solder. I really needed some solder wick, which I don't have at the moment, but do it the easy way. There we go. This up. Soldered itself to the next pin. If I wanted to do that, never would have happened. So that's now loose there. Just need to heat up where it comes through the board, and I can push the wire in. There we go. That's better. That'll work better. Okay. Now I can resolder back to the hole where it comes through. There's a little insulation there actually. Let's pull that out and start over completely. Up. Knock a little blob of solder. That blob of solder on the end, I can, if I have some excess length, I'll just clip that. A little bit of insulation there, and And now you see why this takes time sometimes, because you make mistakes and it takes time to fix them. The trick is not to make mistakes, then you don't have to fix them, and then it doesn't take so long. There we go. Lock that on. Slide this in. Make sure it doesn't fall out this time. Into my solder. Soldered. And this over. Good. This is going to go to this pin over here. I like to run it through the board for more mechanical support, but that's just not going to be practical. So I'm just going to have to wing it on about this much insulation. I'm going to the right pin. This resistor will go to this pin, the enable will go in the center, and the other half of the bridge will go on the outside. Good. I can clip the excess on both sides. Make sure I didn't have too much solder bridging over into adjacent pins. Doesn't appear that I do. We can check that with the meter, clip that, and that's the first resistor installed. And we'll just keep chunking away, resistor by resistor and component by component, and I'm sure it'll get real boring to watch, so I'll turn off the camera and we'll come back later. Okay, we're making progress here. I've got the sockets in, as we've seen. Starting to connect things up. I've connected all of these headers here to the appropriate pins on the chips. And what I need to do, in addition to just connecting to those headers, because I'm going to use a multi-conductor cable to connect this to the actual robot arm through that sub-D connector, I need to plan for ways to get these wires connected out to the outside world, or to connect to the thing. So, for example, this one here, third one in, I can come 1, 2, 3. When I connect the wire, I'll push it through from that side, and if you can see this, it's coming through right here, so I can solder it to the through hole, and I can solder it to that wire right there. And I'll get a good mechanical, good electrical connection, and we'll hook up all of the wires that way. But I'm just chunking away. I've got this populated. I'm starting on this row. I'll get them all connected. It goes fairly easy because these chips are very symmetrical if you look at the pinout. And we'll get back. Okay, as an update, I had said that when I originally laid this out, I had all these headers stuck together in the middle. I said I'd probably regret that, and well, what do you know, I was right. I regret it. So I fixed it. I've removed the original headers, spread them out some, move that one over there. This I'm leaving alone. I think that'll be fine, because that's just really there just so we can clip on these with a scope and make measurements. We're not going to connect any wires to them. And then I can use these headers, now that they're spread out, to plug in and go to the either an Arduino or a separate microcontroller or the National Instruments devices. So I think that will work well for flexibility. I get a lot neater wiring layout here with things not jammed up in the middle. So I think that's an improvement, and we'll just keep soldering away. As you can see, for the most part, I take the I try to take the lead of a resistor, and I put a piece of insulation on that I stripped off when I was making all this stuff here, stripping the ends of these wires, slide it over the lead, put it through a hole, solder it, and then where it comes through the hole, I bend it over until it touches the lead of the chip socket next to it, and then solder that and clip the excess, and away we go. So I'm going to keep soldering, and I'm sure you don't want to watch that, so I'll turn the camera off again, and when I come back we'll see what it looks like.